Hello everybody and welcome back to Unit 9 of Regents Chemistry where we are talking about solutions. Today's topic is soluble or insoluble. So basically we'll learn how to use table F to identify that if you are given a compound, how can you determine whether that compound is going to be soluble or insoluble in water when it makes an aqueous solution. So this is what table F looks like in your reference table packet. And the way it's broken down is that this first column over here, it just says these are all the ions that form soluble compounds, which means all of these things are soluble when dissolved in water. In this second column, however, we are given the exceptions to that. So exceptions to all of the compounds that are given in the first column. So that means these compounds over here, given in the exceptions column, are going to be insoluble when dissolved in water. And then in the third column, once again, all of these represent the ions that form insoluble compounds. So these are all the things that are going to be insoluble when dissolved in water. However, in column 4, we are given the exceptions to that. So all the things that we have over there are going to be soluble when we try to dissolve them in water. So this is what it looks like overall. Your first column is soluble, second column is going to represent all the insoluble things, then third is insoluble again, and fourth is representing soluble substances. Now here, let's say I give you this compound, lithium hydroxide, and I ask you, is this compound going to be soluble in water or is it going to be insoluble in water? We have two things in this compound. We have a lithium ion and then we have a hydroxide polyatomic ion. So if you start going over your table and you will find right here, the very first row in the first column says that group 1 ions are soluble in water. But you still want to keep going because you want to make sure that you don't come up with any exceptions because we have only looked at the lithium part. We still want to find the hydroxide part. So you keep going and that right there you find the hydroxide part. And this one says that hydroxide normally is insoluble. However, the exception is that whenever it is combined with the group 1 ions, which includes lithium, calcium, sodium, potassium, all of those, whenever it's combined with those, it is going to be soluble. So in this case, because it's combined with a group 1 ion, it's going to be a soluble compound when we try to dissolve this in water. Here, look at another example. If I now give you hydrogen chlorate and I ask you whether this is going to be soluble or insoluble in water, you start going over. We have the hydrogen ion and we have the chlorate ion, which is a polyatomic ion. So you find right there that because hydrogen belongs to group 1, it's a group 1 ion. You will notice that group 1 ions are soluble when dissolved in water. And then you have the chlorate, and chlorate is given right there, and chlorate is also soluble when dissolved in water. So overall, this compound is going to be soluble in water. So that was how you use table F to identify soluble or insoluble compounds. Please practice that stuff more so that you guys are well familiar with the table and you're comfortable with using it. Now let's quickly look at how can we differentiate between soluble compounds and insoluble compounds. So when we say something is soluble, we are basically saying that for the most part, most of the particles of this compound are going to dissolve in our solvent. When we say something is insoluble, then that means most of the compounds in that thing are not going to dissolve in our solvent. And then if we have a soluble compound, then that is, as we just said, it's going to have a very high concentration of the ions that are going to be dissolved compared to insoluble, where low concentration of that solute is going to be dissolved. And then one very quick but super, super, super important term to remember is an electrolyte. So basically, if you have a soluble compound that is dissolved in water to make an aqueous solution and it has like dissolved completely, let's say it's an ionic compound, the ions have broken down. Because of those ions breaking down, it's going to be a good conductor of electricity. And whenever you have a soluble substance dissolved in water to make an aqueous solution and it conducts electricity, it's called an electrolyte. If on the flip side, you have an insoluble compound, which is dissolved in water to make an aqueous solution, and then it does not conduct electricity because it's not breaking down into its ions, that's going to be a non-electrolyte or a poor electrolyte because it's not going to conduct electricity. So here you guys know the concept of conductivity, that if something is making ions, it's easier for that, most likely that thing is going to conduct electricity. If something is not making ions, it's most likely not going to conduct electricity. So this thing right here is just giving it the names. So good conductor is an electrolyte, bad conductor is a non-electrolyte in solutions. And then finally, when something is insoluble in water, it also most likely can form a precipitate. Alrighty, that was it for now. Take care. Happy learning. I'll see you in the next one.